Okay, Bergson holographic theory of mind. Continuing, part 57. We're looking at George Buzsaki and his theories of the hippocampus. We're going to see that we're talking about a reference system for the specification of velocities in the outside world, inside world, and scales of time, and being led to looking at this in the terms of the gelatinous brain, or the jello brain. We'll be seeing that we're breaking AI in its notion of computation. And this is not going to be a storage model of experience, though Buzsaki thinks it is. So let's take a look. So stage setting. We've been seeing or saying the brain is essentially a modulated reconstructive wave. So our brain, and that is passing through the external holographic field, as Bergson argued, and it is specific as a wave or specifying a source within the field. A coffee cup with stirring spoon, with a fly buzzing by, being specified at a scale of time, a buzzing fly, wings a blur. The brain's energy state, I've said, sets the scale of time at which things are specified. So the buzzing fly could have been a heron-like fly or an ensemble of electrons or more. If the wings are beating like a heron's, then the fly is actually moving by that coffee cup more slowly at a lower velocity. But how is the velocity, the value thereof, specified? It must be relative to an internal reference system. Reference system. Yep, we're back to the parrot. Let's define 1 second as equal to 1 cycle of a turntable. Each time his tail passes that post. That is what's required. Physics needs a reference system. Now, if you travel 2 feet in this cycle, as our rat there is, we're going at 2 feet per second. So that is, if he travels 2 feet while the parrot cycles, we've got 2 feet per second. But what if I speed up the reference system? That is, I speed up the turntable by, say, 2x, double it. Well, now the velocity of the rat is halved, 1 foot per second. So the speed of the reference system, shall we say, is all important for your measurement of velocities. So take Mr. Cat there, who wants to intercept the mouse running by his visual field at point D, the last point there. The velocity of the mouse is specified such that Mr. Cat knows he must initiate his leap when the mouse is at A, the first point. And essentially, we've got a function relating the minimum velocity, the cat's minimum velocity leap, to the mouse's distance along the trajectory. It's going to become asymptotic. The closer to D, the more impossible, or higher the minimum velocity gets to be until we're beyond light speed. The specification of the mouse's velocity is, again, relative to Mr. Cat's internal reference system and his capability for action, and it's with respect to his action systems. This, we said, is perception is virtual action. Bergson's principle, perception is virtual action. Mr. Cat is seeing how he can act in a specific scale of time. Note, all horizontal lines, by the way, just to bring in Gibson for a second, along that texture gradient, starting from the rat himself, project the same distance, h, on the retina. So how do you actually disambiguate distance? You're going to have to use that texture gradient info the rat is running along. That's required to disambiguate the true distance away of the mouse, just to make a little note on the complexity, actual complexity of things. So now let's introduce a catalyst into Mr. Cat that has raised his energy state, that has increased his chemical velocities. Well, now you've increased the velocity of the internal reference system. You've sped up the turntable. All perceived velocities will be lowered, indicating symmetrically a new capability of action. The mouse is now moving more slowly, and Mr. Cat can wait to initiate his leap. Say, wait till Mr. Mouse is at the point C, and he's still able to get them. So his function has changed a bit. Again, perception is virtual action. This must be so, or perception is not veridical. Otherwise, if he's not seeing how he can act, Mr. Cat leaps, but the weights still see, but the mouse is long gone. Again, it's the body's form of reference system. The cat is not and cannot be measuring with rulers or clocks. So we're going to be asking the question, well, just what is this reference system? Now, I stress this implication of Bergson's virtual action principle in my good old 1976 PhD thesis and subsequent articles, but no notice. And we're still going to see that, no notice. And this brings us to Dr. Buzsaki. So Judge Buzsaki, is Biggs Professor of Neuroscience at New York University School of Medicine. And he wrote this recent book, The Brain from Inside Out. And his talks and vision is getting some attention. I've transcribed that lecture there, the 2018 lecture. But I find Buzz kind of hard to understand given his presentation style. In the book, 400 plus pages is very wide-ranging, and we'll hit a few things in it. But I'm interested in the core of this article, sort of grind some of the book down. That's mainly what we'll look at. As the core, as you can see, is on the hippocampus as a sequence generator. So a couple notes about the hippocampus complex, or hippocampus. For rodents, you see it's much larger relative to the brain. It's pretty large relative to the brain. Its major fraction of things is sensory inputs and motor outputs. Basically, that's it. For people, again, it's smaller relative to the total mass, and the major fraction of the hippocampus seems to be devoted to more complex functions. For example, you can see that there's lots of question marks there that it's pointing to in the higher cortical areas, as well as to other things like memory, etc. So it's doing a lot more. In general, it's an extremely central processing structure. It's coordinating the optical version of events, sonic touch with motor action, and Buzsaki argues with past experience and other things, planning. What it's actually doing and how, it's been a major research question for, say, at least 75 years, since Scoville cut away a good chunk of the hippocampus in a patient called Mr. H.M., and probably before that, probably maybe 125 years. In his lecture, Buzz opens by questioning the usefulness of the classic Newtonian notions of space and time. In this, he characterizes the Newtonian space and time as space being a great container, and time what happens inside the container. This is a bit unfortunate because he's not getting specific enough. The truth is, he's talking about the classic metaphysic, where the container is actually the 3D continuum of points / positions. We've got the 2D there, but make it a box in your mind, a box of points, positions. And then where time or motion just becomes a sequence of those static points across the continuum within the 3D continuum. And time then just becomes, we add a fourth dimension, the four-dimensional box of these points, positions, where the points now become instants in that fourth dimension. He sees episodic memory, that becomes the task of divining in this, or defined in this Newtonian context, the what, that is the content that is stored, our coffee stirring somehow, how the time thereof is stored. And by the way, notice the features, that event is broken up into features. By some definition, by some method, we don't know not how the features are defined, but they're stored in various cortical spots by no principle we know of. And then you have somehow the time that occurred, and by implication, you'd need the time of every instant that hand is circling, stored in some time place, and the space or where it occurred and where it's stored. And it can get worse than that. So, space and time must somehow be measured. And in the Newtonian era, this became rulers and clocks, and still is. Thus, distance and duration, measuring distance and duration. This seems to reinforce that space and time are independent of each other because we've got two different measurement devices. Any notes, other practical questions? If you look at the now or here, so either spatially or temporally, this is either the end of a distance or the end of a duration. So a duration is something between two distant points. Okay, and he says the two are interdependent, distance and duration, and one assumes the other. So he invokes the space-time of Einstein. He says these two axioms serve well. The problem was Einstein came along. People debated and said, maybe space and time are not independent. Maybe there is no such thing as a time arrow, and things like that. Did it have any effect on neuroscience? But noting physics' utter confusion on time, well, not so much effect on neuroscience. He notes Einstein's definition there. Time is what is measured by clocks. So this is a practical answer. It sweeps the problem under the rug. I've read every book on space and time written by physicists. The interesting thing that you summarize in a sentence is that the last chapter of every one of his books, every physicist's books, is always about God. The reason for that is that they don't have a good solution. My answer is that it's not a physics problem, it's a problem for neuroscience. And I think it's a problem for philosophy. I've harped on this confusion, though, especially in the last couple ones. That is, physics' complete confusion over time. Yeah. Is there a flow of time? No. Oh, yeah, there is. Well, the time reborn, reality of time, end of time. Utter confusion, and I've noted the utter uselessness, just like Buzz did, of special relativity for a theory of consciousness. It can't have any effect on neuroscience. It's unusable. It's useless. It's a joke. But going on. Let's say what Buzz is getting at a bit more succinctly. This. The brain does not dwell in the space and time of the classic metaphysic, that continuum of points, positions, with its fourth dimension of instance. This, the classic metaphysic, is a conceptual derivative of the brain, but it is not the world in which the brain is actually embedded. It's not the field in which the brain is embedded integrally. Buzz does not grasp the implications of this. But distance and duration, we're back to the reference system. Note the reference system is itself a distance, the distance that tail is swirling around. With a unit of time being really a spatial simultaneity each time that tail passes that point in space, the post. The conjunction of tail with post. Again, speed up the occurrence of the simultaneities. Triple the time of that tail flying around, or the velocity that does so. The velocities are halved, quartered, etc. But has the flow of time of the universe actually changed? Even this, then, is not time. Yet the brain itself must specify velocities. Remember Mr. Cat's problem. It's not going to be via a turntable. This is where Buzz comes in, very interestingly. The hippocampus contains cells with place fields. So a rat here, as he moves around an area, as he comes to a certain area, the place field will fire in a roughly close proximity. And these fields can cover 20 centimeters to 300 centimeters. Thus, the place fields from several neurons can overlap. And these neurons are phase locked in the theta cycle. So there's our theta cycle, those big sinusoidal waves. There's little jags there are the gamma cycles within a theta cycle. And nested within each is a cell assembly whose activity corresponds with a given spatial position. So here we've got place cells. Notice green cells and the blue cells, the vertical spikes, or the green for the place cell, are where that place cell is firing within the theta cycle. And notice there's a little offset from the place cell for this blue and the blue spikes. Enough for now. T, the big T there, is the time needed for the rat to run the distance between the peaks of the two place fields. Notice the green has a peak and the blue has a peak. That's where the spikes are the thickest. That's the peaks of the place fields. And then T, a little tau, there is an offset between the two neurons in the theta cycle. So as the rat moves, new place cells join the existing assembly in the theta cycle, while spikes of the place cells whose field the rat has just left disappear. So above we've got a theta oscillation. We've got the descending part of the theta oscillation, the early part, and the ascending part of the oscillation, the late part. And as you know, neurons with upcoming place fields fire at the late phase of the theta cycle, and whereas neurons with the recently passed fields right in the early phases. So they're like neuron 1 is at the early phase, descending. Neuron 2 starts to come in at the late phase. Neuron 1 fades out, and now neuron 2 is at the early phase. So as the animal moves forward, the sequence position of a particular neuron moves from the ascending late phase to the ascending early phase of the theta cycle. So this one in, one out deal of the place fields in the theta cycles keeps the number of cell assemblies constant. Number of place cell assemblies firing all the time. So before I get going here, let me note that Buzz is quite concerned to show the equivalence of the relationship of these three terms. That is, given 2, we can always derive the other. Given velocity and duration, we can compute distance, d equal vt. Given distance and velocity, we can compute time, or we compute the duration. So given 2, we can always compute the third. And we're going to see this played out in the hippocampus. So the green and the blue neurons have a spatial relationship. Each has a peak, as we noted. The blue one's the thick spike there, and the other thick spike for the green. And we can measure the distance between the two physical spots, say on the mat the running's on, or in the maze. Let's say it's 9 inches. But we can also see that it's precisely related to that big T, the time. That is, we can ask the temporal relationship between the two neurons inside the brain. And we can see that the distance in the outside world is translated to time, 9 inches to the big T. And of course we can ask, well, what if the rat is going fast versus going slow? Can't always have the same constant speed. That seems to work there. We'll say the rat traverses the place field of the neuron, and this first time he tries it, he does it in 1 second. So the place cell then is, we'll call it a slow movement. There's 8 thetas, roughly 8 theta cycles. Now he moves faster in trial 2, much faster. Again, that horizontal area there is a time in the place field. Well, now he's active 4 thetas, or that place field is active just 4 theta cycles. So the number of spikes within the place field varies little. Notice there's still roughly 7 spikes each time, even if the velocity of the rat changes. Thus, the number of place spikes about the place, per theta doubles. Owing to this firing rate gain, which reflects a stronger excitation with velocity, he says the magnitude of the cycle-to-cycle theta phase shift increases proportionally. Now, I'm going to admit I'm not quite sure what he means by that, but I'm putting it out there for people that tune into that more quickly. I still haven't quite seen what he says, but that's okay. Don't truly need it. Thus the velocity gain, though you can see this, compensates for the shorter time in the place field. The relationship between spike phase and spatial position stays relatively invariant. So the faster the animal runs, the faster the voltage oscillation of the place cell is. And he says, thus, as in physics, the brain is capable of equating distances and durations through velocity-dependent modulation. Okay, like we started with the last slide, you can derive v from d or t and t and vice versa, etc. Having said that, moving on just a little bit more for Buzz. Buzz still holds the hippocampus as an index into multiple fragments of the event stored in the cortex. So here a picture, all those little circles are areas in the cortex, visual areas, auditory areas, somatic bodily areas, olfactory areas, okay, all the cortical sensory modules in the cortex. He says the key difference between our current perspective and the indexing theory is the ordering of events. Instead of a single index that points to cortical modules, the unit, in our view, is a sequence of indices. Notice the sequencing where all those nice curvy lines are pointed to. A sequence of indices such that the hippocampal system is responsible for concatenating neocortical information, so all those little circles, neocortical information chunks into sequences for both encoding and retrieval. And episodic memory becomes. In the proposed sequencing theory, episodic memory is simply an ordered sequence of translationally invariant whats and the related context, another what, with no explicit internal representation of space or time. So all those cycles, those theta cycles and place cell spots within the theta cycles are taking care of the need to store different things in space spots and time spots in the cortex, he's saying. So what he's saying, though, is relative to my coffee cup stirring, with its velocity flow fields, adiabatic ratios, inertial tensors, that this event is being parsed up into little chunks and placed in various areas in the cortex. Not only chunks of the event itself, but chunks in time. So you've got the sequence of whats, or snapshots. That's the sequence of whats. And then you'd have the context, which is I'm doing this in the kitchen, or I'm moving around in the kitchen and taking my coffee cup into the living room itself. So another piece of the what. One sort of asks, well, how is the color of that coffee cup being stored in the dark brain? Hard problem sort of floats back in. So stop for a second. Is this computation? It looks like a complex system of biogears. Gears made of biojello, like jello gears. I don't know how else to say this, but resonating biogears, I'm even going to say. Like gears, a vast interlocking system. Buzz is driven to use another metaphor. It's almost solid metaphor in his book. Activity travels in neuronal space. You're still thinking of an abstract space, much like waves in a pond. But this is more than just an abstract space. This is a real biochemical field. So the values, like velocity equals distance times sine, v equals dt, are not really being computed as values, e.g. 5.2 feet per second, and then fed to a subroutine for more computation. E.g. in my little cat picture here, we have a module that computes the velocity of the mouse, 5.2 feet per second, passes that to a module in the cat, another module somewhere that computes the velocity, the v-min of his jump velocity. Subroutine to subroutine with values being passed. It's not that. The gears are neurons. But how apt is the gear analogy? And can the whole system of gears be sped up? Remember, in our reference system. So what follows? Take a little bit different look at buzz. What follows comes from the thoughts of my biochemist collaborator on LSD, Dave Logan. This is as we considered the potential of how the action potential, the fundamental driving electrical velocity through the neuron, can be sped up. Just particularly the action potential of these detecting neurons as the wings pass those detectors and the detectors fire. How could that be sped up to produce the heron-like fly? The gears, or the working parts of any oscillating system, are solid. Thus, they're not overwhelmed by heat loss. Either the gears of our cortex there or this pendulum of our clock. Notice we're talking velocity-dependent oscillators. We're talking oscillators there. If not solid, they'd easily be overwhelmed by heat fluctuation and proceed to a high entropy state, that is, huge disorganization. They'd fall apart. Yet remember our neuron picture in number 44 on LSD, Wendy Riggs. The neuron is bathed inside and outside in a chemical, watery liquid soup. So a watery soup inside and outside. Inside you've got calcium, sodium. Outside you've got potassium, K+. And the neural membrane separates two phases of electrolytes, those electrolytes in the soup. On stimulation, sodium or voltage-gated channels open down in a series, channel after channel, and the voltage change, namely the action potential, passes, quote, down the neuron. That's in the standard model. As the electrolytes move from one side of the membrane to the other. That's important. Do you really have to visualize this as channel after channel after channel? That's what we're getting to. In fact, here's the puzzle of the action potential. Why is the system oscillating or in phase with itself? For the action potential is an oscillating neuron. That is, why do you have the theta rhythm or the alpha rhythm? Heat dissipation demands that a watery electrolyte proceeds to high entropy very quickly. No known electrical device reabsorbs heat. Heat is only ever dissipated by electricity, not reabsorbed. Think your standard stove. You somehow need the solidness of a pendulum, where you can give it a very low energy input to keep it swinging, and have it oscillate without being overwhelmed by heat fluctuation. Well, this brings us to the association induction hypothesis of Gilbert-Ling. Now, Gilbert-Ling is unliked. He and his association induction hypothesis are suppressed heavily by biochemistry. In fact, his induction AI hypothesis, if you want to read it, you're not going to find it on Wiki, but rather on Deletionpedia. It was deleted from Wiki. It's that disliked. I'm just going to comment. The ills and disciplines related to consciousness, physics, cognitive science, biochemistry, pretty multidisciplinary. We're going to replace the watery chemical soup. We're going to visualize the brain as a big block of gelatin, a protein, gelatin is, that keeps water in a highly, highly organized state. Gelatin is mostly water, yet it behaves as a solid. The water is adsorbed, not absorbed, onto the gelatin. It is not in a free state. So if you look, absorption occurs when a liquid, gas, or dissolved solid is adhered to the surface of the absorbent. So not absorption, adsorption. The electrolytes also not free. Ling demonstrated exhaustively that all positive ions, like positive potassium, or K+, are bound to their opposite charge of the cell, bound to each other. They are associated, quote unquote. That's the association part of this AI hypothesis. They're not just sitting there, not just floating in space, as a standard vision would have it. They're not waiting to be channeled to either side of the membrane, as convention claims. The water is associated with the brain, take a note, as well, not free, just as it is in a gelatin. In fact, studies on meat have shown water cannot be centrifuged out of meat, even at very, very high speeds of centrifuge. So the conventional picture, you've got a membrane with channels, bathed in electrolyte in a watery soup. But with Ling, a gelatin, onto which water and ions are tightly associated. This is why the brain can oscillate. The water and ions are in such a rigid state that they overwhelm heat dissipation and thermal fluctuation, like the gears or a pendulum or a watch. The gears are made of the protein or water or the electrolyte mixture, which is in a highly organized solid condition. Now we are approaching why there can be theta cycles and alpha cycles, and why place cells are phase locked in these cycles. One point first before we go on. The physical state of a gelatinous system can be modified by its surroundings. Try to make jello with vinegar added. Depending on how much vinegar you add, the jello may not solidify. It may form many separate orbs, surrounded by liquid water or whatever. The key is the adsorption of water and ions is conditional on the state of the gelatin, and it is, quote, cooperative. At a certain acidity, all of the water will be free. Therefore, the water cooperates, going from one side to another based on the acidity of the jello. Another example is a water softener. Ions are kept in or out by the choice of the size and acidity of the rosin inside, and they will all absorb to the rosin together or not at all. So for Ling, the acidity of this gelatinous mixture is under the control of a small number of molecules, this being termed the Cardinal Absorber, small number of molecules. When ATP is present, the fixed negative charges of the living cell have a preference for potassium. It's RK plus inside there. When the neuron fires, quote unquote, the ATP is lost. Now the fixed negative charge does not prefer potassium or sodium. The sodium will come rushing in, or on the conventional picture, the channels are opening. Rather than seeing an individual neuron, then, the whole brain, with its hippocampus inside, is a gelatinous mass under the control of ATP and other important molecules. It goes back and forth from preferring to absorb potassium in highly organized water to having no preference for either. The generation of ATP by our metabolism is therefore the small energy input, like pushing a pendulum, that keeps the whole cycle going. So another important piece, when the electrolyte leaves the cell, the stuff outside the cell, between the neurons, is not meaningless. It, that is the space, is coordinating the whole mass. That is why Thoke and colleagues show that all billion yeast cells in a culture are in phase with each other, so long as the density is high enough. The space between the neurons is shared in coordinating the phase locking. It's all one giant gelatinous mass. So we ask, why supposedly membrane channels and pumps? The key here is that these work on the basis of ATP as well. So if you take a single pump and study it in solution, separate from the rest of the cell, which is the entire basis for biochemistry, you may come to the conclusion that it is pumping across the membrane that is powered by ATP. However, this is a leap of faith, since the single pump itself will act like a gelatinous colloid. So you're really just seeing a very small version of the entire cell, indeed the entire brain, how that would act. In the presence of ATP, the pump prefers one ion, otherwise it has no preference. How do we speed up these phase lock cycles? How? Well, there's LSD. LSD is a very high valued induction index. In electronic action, it acts as a cardinal absorbent. So it starts to control the whole gelatinous mass, like ATP, but more powerful yet. So the oscillation of the entire mass, or at least the portions LSD affects, is sped up. The frequency of the cycles, theta, alpha, increases. The specified scale of time changes. The fly becomes heron-like. The spoon circles more slowly in the coffee. The swirls in the coffee slow down. The mouse is moving more slowly by the cat. Speech, as heard, slows. And yes, the hippocampus with its cells locked in the theta cycle is an essential cog in the specification of events, their velocities, their motions. These are objective effects, not hallucinations. And so, if you notice, we're leaving the AI conception of the brain in the dust. So why leaving AI's brain, the concept thereof, in the dust? Well, this is obviously a concrete dynamics, not abstract symbol manipulation that's implementable on anything from an abacus to a register machine with beans and shoeboxes to a Turing machine with infinite tape. But to think on this a bit more, the neuron with its action potential is conceived as a one-way flow of this action potential. At the end, it connects to another with a connection strength. Another stimulus, the neuron fires one way again. This is the basis of neural net conceptions. It's the basis of the matrix algebra underlying deep learning networks. Yes, one can consider the backwards flow, the backward propagation, but in the deep learning world, that's embodying derivatives that start to stretch the plausibility of the whole thing as far as neuronal implementation to the utmost. But the neuron, in reality, is phase-locked in a cycle. For example, the theta. The neuron with its action potential is in reality an oscillator. The cell spikes are relative to the phase. Yes, we're talking the interlocking gears again. This is not an AI neural net in reality. Now, all this, the implications, need more explication, more exploration, yes, a new form of conceptualization. So having said that, let's go back to the hippocampus. Buzz is focused on rats moving through spaces. But what if the rat is stirring coffee? Are there not plenty of spatial and temporal relationships, speed relationships in stirring? Remember our invariant structure, the velocity flow fields, the adiabatic ratio, the ratio of energy of oscillation to frequency of oscillation, inertial tensors, acoustical invariance, etc. How is the hippocampus involved in this? Just this event, which a rat could do, or people can do. As the multimodal event is ongoing, the information, quote unquote, that is the invariant structure is flowing to the various modality areas of the cortex and back and forth to the hippocampus, which is at least expressing, in modern terms, coding, the body's motion positions during the event, like the rat running. Now recall the invariance is amodal. It's coordinate across modalities. A little example here, the acoustical frequency as the water rises as it's poured is proportional with the optical rise in the liquid's height. And there's just a ton of this same kind of thing in our little coffee stirring, amodal invariance, coordinate across the modalities. So the whole brain is humming with the event. So one asks, when are instants, snapshots of the event being stored? And how is a pattern like this being recorded while it's being taken place? How is it recorded simultaneously? An interesting question. So we're going to look at the larger Buzz for a little bit. For the scope of his book is vast. We could talk on Buzz's book for multi-videos. But let's take episodic memory. Buzz holds that his model, or he now has a model of how episodic memory is stored. But as usual, he too has no theory of the origin of the external image, the dynamically transforming image of the external world, of our experience, that coffee stirring. He does not know what experience actually is because he has no model of it. He cannot know how our experience is stored then. His theory is ungrounded. Again, exactly when would anything be stored in this model in the first place, as we just saw? The hippocampus is simply part of a humming system processing resonating to events. When the storage? Cognition. For Buzz, brains with the bodies interact with the world rather than detect it. Perception is what we do, he says, emphasizing action. As noted, there's no model of the origin of the image of the external world in this. Buzz will argue that corollary discharge, that is a copy of quote motor commands, is the physiological mechanism that turns sensory input into experience. In other words, we just to turn neurochemical flows into the coffee cup and stirring spoon, the visual image, we just add more neurochemical flows. The absurdity of this is obvious. But he's going to turn this stance into a theory of cognition, of thought. Cognition is nothing but internalized action. He is recasting the mental into the neural by means of action as a kind of ultimate cognitive primitive. But we've seen this move before. We saw it number 15 when we went through the inactive theories, the embedded theories, the expositors of Gibson. They had no theory of the image of the external world, thus no source for the images of thought. The Gibsonians didn't grasp how Gibson's model of the image worked, because it has to be placed within Bergson. Hence, they have to reduce cognition to something that is not involving imagery. And so total denial of anything like this occurs. A la my favorite thing with Penrose, his visualization of stacking hexagonal numbers, three-faced hexagonal numbers folded as such into successive cubes, always making a cubical number. His proof of non-computational, or example of non-computational thought, nevertheless being a mathematical proof. Or Piaget, children's age 3 to 7, learning the odd-even rule. Beads are run into a tunnel, the tunnel is half rotated, and the beads come out in opposite order, inverted. Now, if you ask, what if I rotate it 3 times, or 7 times, or 6 times? Does the child know what's going to happen? And it takes him from age 3 to age 7 to learn that. And this is part of what Piaget calls concrete operations, which he says are, in reality, schematized visualizations. Once the scheme of visualizing the objects in alternation is set in train, he finally discovers that upon each half turn, the order changes once more. Only the fact that up to this upper limit, the subject continues to rely on visualizing intuitively and therefore needs to image one by one the half turn is proven because he is lost when a jump is made from one number of half turns, say 3. Okay, I can understand 3. How about 7? Can't do it. He's got to visualize them all 7, or he can't get there. He hasn't learned the rule. But the point being, the process is, as he observes it, as Piaget observes it, this child steadily visualizing what's going on, ultimately becoming concrete operations, schematizing the whole thing. But, right, just throw away Piaget. This is standard move for all these people, including Buzz. The temporal metaphysic. Now, Buzz has made inroads into uncritical acceptance of the classic metaphysic. Small inroad, I'd say. Its contrast in the temporal metaphysic, remember the transformation of the universal field, or holographic field, is indivisible motion. That is, time cannot be treated as a series of discrete instances, indivisible, totally, absolutely continuous. But it's the concept of static instant that underlies fixed values, fixed determinate values of velocity or force. This underlies measurements of velocity and duration. Thus, the notion of a fixed instant or fixed instant snapshots of events, with their values that can be stored in static snapshots, static spots in the brain, as we saw. It's the sequence of what's. Now, it's interesting, eye saccades, the saccadic motion of the eyes from spot to spot to spot on that image reinforces this notion of sampling in Buzz's mind. He's got a section called the illusion of continuous vision. And this sampling or saccading seems like discrete sampling of a scene or event. But it's not. A saccade still registers flow. There is constant change no matter how tiny the interval. Just because the eye happens to rest on it in a sort of a discrete motion does not mean the change is occurring. And what supports the illusion of that flow as that spoon and the coffee circle around? What supports the illusion? You've got a new problem. Well, the answer is the indivisibly transforming field in which the brain is embedded in the first place. In other words, the concrete and the classic abstraction, classic metaphysics abstraction of everything, are now utterly mixed and confused in the modern mind. Gibson, in this context, again, as I noted, I'm taking it from him, the saccades register flow. And he says the perceptual system is in a constant action loop, sharpening perception via feedback, detecting invariance. But for Buzz, on the one footnote he has with respect to Gibson, Gibson is dismissed. Gibson, holds perception drives action. This is a nonsensical critique when you just look at what I just said in the first two bullets. In a constant action loop. It's nonsensical. The system is always searching, driven by action, by saccades for information in the information flow. So the bottom line, as I said, the brain does not dwell in or care about the classic framework. There is only constant change, even within the tiniest interval. There is no fixed thing or value to ever store. So, conclusion. If one takes the liberty to expand on the implications in Buzz, like I've just done, one sees we are increasingly being driven away from the AI or brain as a computer notion of mind, and towards a brain resonating, a system of biogears. We need more conceptualization. But yes, for the Bergsonian, always in the background, the building of a basis for the brain is actually forming a concrete reconstructive wave. You can see we're getting there. But these implications remain far away from the mind of Dr. Buzz, perhaps because they're just too unthinkable. So next we'll see. So then, signing off.